Welcome back to GED Advanced Geometry. Take a slow breath and let's build this together one small step at a time. Last session, we learned a squared plus b squared equals c squared. Today, we put it to work. Right triangles are hiding inside ladders, ramps, diagonal screens, rectangular fields, and even the distance between 2 points on a grid. Once you learn to see the hidden triangle, all of these become the same problem. The key skill this session is spotting the right triangle inside a word problem. A ladder leaning on a wall makes a right triangle. The wall is one leg, the ground is the other leg, and the ladder itself is the slanted hypotenuse. The same is true for a ramp or a diagonal path. Whatever is slanted, going corner to corner, is the hypotenuse. The two straight directions, up and across, are the legs. Let's work a full example, slowly. A ladder reaches 12 feet up a wall, and its base is 5 feet from the wall. How long is the ladder? Step 1. Sketch the triangle. The wall is a leg of 12, the ground is a leg of 5, and the ladder is the hypotenuse. Step 2. Write the theorem. 5 squared plus 12 squared equals c squared. Step 3. Compute. 25 plus 144 is 169. Step 4. Take the square root. The square root of 169 is 13. So the ladder is 13 feet long. A diagonal drawn across a rectangle splits it into two right triangles. The length and the width become the two legs, and the diagonal is the hypotenuse. So d squared equals L squared plus W squared. For a television screen that is 16 inches wide and 12 inches tall, the diagonal squared is 16 squared plus 12 squared, which is 256 plus 144 equals 400. The square root of 400 is 20, so the screen is 20 inches. Here is a beautiful idea. The distance between 2 points on a grid is just the hypotenuse of a right triangle. The horizontal change, how far you move left or right, is one leg. The vertical change, how far you move up or down, is the other leg. So the distance formula is really the Pythagorean theorem in disguise. D equals the square root of the horizontal change squared plus the vertical change squared. Let's work a full example, slowly, using the points A at 1, 2 and B at 7, 10. Step 1. Find the horizontal change. 7 minus 1 is 6. Step 2. The vertical change. 10 minus 2 is 8. Those are the two legs of our right triangle. Step 3. Apply the theorem. D equals the square root of 6 squared plus 8 squared, which is the square root of 36 plus 64, the square root of 100. Step 4. The square root of 100 is 10, so the distance from A to B is 10 units. Not every distance needs the full formula. If 2 points share the same y value, they lie on a horizontal line, so you just subtract the x values. For example, from -2, 3 to 4, 3, the y values are both 3, so the distance is simply the absolute value of 4 minus -2, which is 6. The same shortcut works for points that share an x value. Then you subtract the y values. Only slanted distances need the square root. Before we finish, let's dodge the 3 most common traps. First, the diagonal is the hypotenuse, never a leg. Do not put it on the wrong side of the equation. Second, use the absolute change for the legs. A distance is never negative. And third, do not round too early on your calculator. Keep the exact value until the final step. These small habits protect a lot of easy points. Excellent work today. You can now find a hidden right triangle in a word problem, compute a rectangle's diagonal, and measure the distance between 2 points on a grid. Your mastery check is the 10 practice questions for this session. For each one, write it out this way. Given information, then formula, then substitution, then the answer with units. To read the full lesson notes and practice more GED geometry questions, visit the course page at www.bridgetoexam.com. I will see you in the next session where we begin volume. Keep going, you are doing great.